Hi, this is Mrs. Secorn. If you could write your name on your notebook, I'd appreciate it. This unit is going to be on geometry, just some topics with geometry. Um, we talked about this on Friday. The sum of the measures of the angles of a triangle, the sum is 180 degrees. So if we know two angles, 20 and 120, we know the whole triangle sums to 180. We'll take 180. Let's see, we'll find the sum of these. 120 and 20. Isn't that 140? And we'll subtract 140 from 180. And we'll find the missing angle is 40 degrees. So x equals 40. The next one. All right, a triangle sums to 180. So we have 90 and 65. That gives me 155. And if I take 180 and subtract 155, let's see, borrow, it'd be 7. 10 minus 5 is 5, and 7 minus 5 is 25. So x is 25 degrees. Now, my geometry students know that if you have a 90-degree angle, you know these two have to add to 90. See how 25 and 65 add to 90? Because they know 90 and 90 will give me 180. So if you do see a right angle, you could just say, well, these two have to add to 90, and take 90 minus 65. Okay, so the other topic we talked about was the names of triangles. So on the green side here, we'll talk about the angles. If all the angles in a triangle are acute, then we call it an acute triangle. A-C-U-T-E. Okay? If one angle is obtuse, then we call it an obtuse triangle. And if one angle is right, we have one right angle, we call it a right triangle. Why don't we go down here and classify the triangle by its angles right now? Let's use green to match that up. So we're going to use one of these, acute, obtuse, or right, for this triangle. Looking at ABC. We'll see how the 102, that's an obtuse angle, so it's an obtuse triangle. And let's look at this one, 60, 60, 60. All of those angles are acute. They're all less than 90. Remember, a right angle is 90. So this is called an acute triangle. All right, let's go back now and name it by its sides. When we have no two sides equal, we call that scalene. S-C-A-L-E-N-E. And when we have two sides congruent, we call that isosceles. I-S-O-S-C-E-L-E-S. And when we have all the sides equal, we call that equilateral. E-Q-U-I-L-A-T-E-R-A-L. Okay, now let's go and name these two triangles by its sides. We have 2.3, 4, and 5. All the sides are different. We call that scalene. Okay, and this one, all the sides are equal. This mark means they're all equal. We call that equilateral. So a triangle has two names, one by its angles, another by its sides. Okay? I wrote this down. This triangle is very special. All sides equal, all angles equal. It's also called equiangular. We know they're all 60, 60, 60 because 60 times 3 gives me 180 and makes it a special triangle. Then the final thing we talked about was the Pythagorean theorem. This only works for a right triangle. So in a right triangle, the square of the hypotenuse, now that's the longest side, that's the C. Let me put this up here, there's a blank here. The C is equal to the sum of the squares of the lengths of the two sides A and B. So the squares, see A squared, and then the sum means add, B squared, the two legs, equals the hypotenuse squared, the longest side. Okay, when I say legs, I'm talking about the shorter sides, and C, hypotenuse. Okay, so here we have a problem. A is equal to 3, so we'll plug that in. B is equal to 4. Plug that in. We need to find C. We can use Pythagorean theorem because we have a right triangle. So we'll say C squared, see, hypotenuse squared, equals 3 squared plus 4 squared, the A and the B. All right, so C squared equals 9 plus 16, and then C squared equals 25, excuse me. Okay, we know this side isn't 25. If that's just 3 and that's 4, that'd be way too short for 25 because it's C squared is 25. So we have to take the square root of it to find the answer. And the square root of 25 is 5. Because 5 times 5 is 25. Let's go out to our calculator and just plug it in because that one worked out nicely. Okay. So if I want to find the square root, I have to, above your x squared key is your square root symbol. And then you can plug in 25 and close parentheses just for good habit. And then you'll find out it's 5. Can you see it? Okay, thank you. Let's go on just a little bit more. Okay, the distance between 2 points. You know, on a number line from A to B, I could find this distance. This point is 1, 2, 3, and this would be -1, -2, -3, -4. That's probably -4.5. To find the distance here from 0, wouldn't I add 3 and -4.5, the distance? Now, when I do that, I don't want to say 3 plus -4.5. I kind of got that wrong. I want to say this distance is 4.5 and this distance is 3. So the whole length of this is 7.5 or 7.5. The 3 here and then the 4.5. Okay. Well, we're going to the distance formula here. Oh dear, I think I need a little more room, so I'm going to do something that you can't do on your paper. Just going to move that up. We're going to find distance on a coordinate plane. What is the ordered pair for G? Let's see, we got 1, 2, 3, 1, 2, 3, 4. So the ordered pair for G is 3, 4. Remember the X and Y. This is the X-axis. This is the Y. And the ordered pair for F, I'll put that in blue. The ordered pair is 1, 2. Okay, I want to find this distance. Okay, it's not 2 because it's on the diagonal. This is 2. This is 2. But this is not 2. It's longer than 2. Okay. So we use this formula. Maybe you've seen it before. It's called the distance formula. I'll give you the formula on the test, but you need to know how to work it. what we're going to do is we're going to subtract the x's and square it. So the x's are 1 and 3. So I think I'll say 3 minus 1, right? 3 minus 1. And then 4 minus 2. Those are the y's, right? 4 and 2. All right. We got that square root symbol like we did in the Pythagorean theorem. As a matter of fact, this is the hypotenuse of this triangle. This leg's 2, this leg's 2, see? And that's the hypotenuse. There's the right angle. So we have 2 squared plus, and then 4 minus 2 is another 2 squared. So it's the square root of 4 plus 4, or the square root of 8. That's what the distance is. So now we need to go to our calculator. And let me clear it. We want the square root. Oh dear. I've wrecked the calculator, guys. I cannot bring that down. Okay, the square root of 8. I don't think I'm going to be able to do it, but let's try it. Second square root. No, clear. All right, we'll do that later. And thank you. Bye.